Okay, Trig kids, I'm going to attempt to make some notes for you guys for your homework. So I'm going to do some practice problems here from section 7.1. You will have to turn up your volume because I can't find a good mic right now. I've got another one coming in that's supposed to be better, but right now we're suffering through this. So I'm going to put some practice problems on the board. I hope these come in handy. Here we go, section 7.1. First problem, 5 times cosine t tangent t. Now, the trick to these is you want to rewrite any of your trig functions that you possibly can using sine and cosine. So obviously cosine is fine, but the tangent function we can rewrite as sine over cosine. So that's what we're going to do. Now you'll notice that I've got a cosine on top and a cosine on bottom. Those will cancel. So this just ends with 5 times sine t. That would be your answer. That is all you can do with it. Okay? Another one. I've got cosine t times cosecant t. Now, if you remember, cosecant t is 1 over sine is our cosecant function. So let's rewrite it. Now, that gives us a cosine on top of a sine. If we multiply them together, and cosine over sine is cotangent. Not sure what happened to my t there on the cotangent, but that is cotangent t, C-O-T-T. Okay, what about having tangent squared x minus secant squared x? Well, tangent squared x minus secant squared x. Tangent squared x, again, we are going to find or rewrite that in terms of sine and cosine. Okay? So this is sine squared x over cosine squared x minus secant, if you remember, is 1 over cosine. So secant squared is 1 over cosine squared. So now we have common denominators. Okay? Remember, when you add or subtract fractions, you got to have common denominators. So now we have sine squared x minus 1 over cosine squared x. Well, sine squared x minus 1, you'll notice in your PowerPoint some basic trig identities that I had included. Basic trig identities, the big one, the overall arching one that we know is that sine squared plus cosine squared equals 1. Okay, that is a major trig identity. Sine squared x plus cosine squared x equals 1. Now, that comes from Pythagorean's theorem, and it comes from, if you remember on our unit circle, sine is your y-axis, cosine is your x-axis. So sine squared plus cosine squared equals 1, Pythagorean's theorem. Okay, so what would sine squared x minus 1 be? Well, sine squared x minus 1, if I rearrange this trig identity over here, if I have sine squared x and I pull the negative 1 over, then that means I have to pull the cosine squared over. That is negative cosine squared x. I just rearranged that trig identity. I subtracted the negative 1, moved it to the left, subtracted the cosine squared, moved it to the right. Well, isn't that what our numerator is sine squared x minus 1? So, my problem then, the numerator becomes negative cosine squared x over cosine squared x. Then we can cancel out the cosine squared x's. And what does this leave me with? A negative 1. That is all it reduces to, is negative 1. Let's keep going. Next one on my list is secant x over cosecant x. Secant x over cosecant x. Well, again, the goal here is to rewrite them using sine or cosine. So secant is 1 over cosine, and cosecant is 1 over sine. So this is going to give us an ugly complex fraction here. Again, secant's 1 over cosine, cosecant is 1 over sine. So this is the same thing then as 1 over cosine x divided by 1 over sine x. Well, this is 1 over cosine x, I'll get it right here, times sine x over 1. Okay? Well, that leaves us with sine x over cosine x, which is the tangent function. So final answer would be tangent x. Okay, moving right along. We have lots of these. I'm going to do quite a few of them. Next one I have is sine u times tangent u plus cosine u. Okay, tangent, once again, we need to rewrite as sine over cosine. Now, this gives us sine squared u over cosine u plus cosine u. Now, in order to add or subtract fractions, we have to have common denominators. Well, right now, this cosine u has a denominator of 1. So I've got to get it to have a denominator of cosine u. So I have to multiply the top and the bottom by a cosine u. If I do that, then I'm going to have sine squared u over cosine u plus cosine squared u over cosine u. Okay? All we're doing here is playing algebra with trig functions. That's all we're doing. Now, we've got common denominators, so I can combine the numerators. So I've got sine squared u plus cosine squared u all over cosine u. Sorry, I've got a couple dead spots on my board, as you all know. Now, sine squared u plus cosine squared u. That's the trig identity we just talked about a problem or two ago. Sine squared plus cosine squared equals 1. Pythagorean theorem. So this is 1 over cosine u, and 1 over cosine u is the trig function secant. So again, all we're doing is doing some basic algebra with trig functions. Okay, so that finished up problem 5. Let's move on to problem 6. I have cosine squared theta times 1 plus tangent squared theta. Now, I'm going to stop putting the parentheses around the u's, the x's, the thetas, just because it's wasting too much time. So when you put this in WebAssign, you may still need those parentheses. Just keep that in mind. So here we go. Now, cosine squared theta times 1 plus tangent squared theta. Now, this 1 plus tangent squared theta is another trig identity. We talked about the one earlier that was sine squared plus cosine squared equals 1. Well, this is another one. Tangent squared plus 1 equals secant squared. So let me write that down. Let me also say that in your trig folder in Google Classroom, I have uploaded a trig cheat sheet that has all kinds of properties of trigonometric functions and the trig identities. It's 4 pages. It's a PDF. You can pull it up on your phone or your computer, or you can print it and have it handy. But it is in the trig folder on Google Drive in our Google Classroom class drive folder. I think I repeated myself. But anyway, it's there. But this is trig identity. So one of the basic trig identities, along with sine squared plus cosine squared equals 1, is tangent squared x plus 1 equals secant squared. So we are going to use that trig identity to substitute in secant squared in place of that parenthesis part in our problem. Now, whether you're using theta or x or u, it doesn't matter as long as you're consistent. Now, we also know then that secant is 1 over cosine, so I'm going to rewrite that. So now we've got both pieces in terms of cosine. Let's combine them into one fraction since we're multiplying. Cosine squared over cosine squared, of course they're going to cancel. And it just equals 1. Okay, I want to do one more, and then I'm going to conclude this first part. There are 28 questions in this section. I plan to literally do all 28 for you. My problems may not be the same as your problems, but I know that trig identities can get tricky. So I wanted to make sure you had plenty of examples, okay? Not only do you still have your watch-its, remember you also have online ebook that you can get to via WebAssign, but wanted to make sure you had plenty of examples. So I'm going to do one more in this part 1. This is going to be a 4-part note section here for section 7.1, because I know this is all brand new. Problem 7, mine is cosecant theta minus sine theta over cosine theta. Now, once again, we need to write everything in terms of sine and cosine if we can. Unless there's a trig identity substitution we can make. But cosecant, remember, is 1 over sine. So that's where I'm going to begin. Now, once again, we have an ugly complex fraction. On top, I'm just going to focus on the top for a minute. We have got to get common denominators, which is just going to be the sine theta. So I've got to multiply that second part of the numerator by sine theta, top and bottom. Now, on top, we have common denominators of sine theta. So I can combine that together now. Now, remember, the big fat fraction bar, this big fat fraction bar, is just a division symbol. Okay? So, this is the same thing as, well, and before I go any farther, this is also trig identity. So that is going to equal cosine squared theta. 1 minus sine squared theta equals cosine squared theta. Again, remember the trig identity is sine squared plus cosine squared equals 1. So this is cosine squared theta over sine theta divided by cosine theta. I'm moving down now, I'm running out of board space. Divided by cosine theta means we multiply by 1 over cosine. Now, one of the cosines will cancel, top and bottom. Now on top, we've got a cosine squared. We have two of them. So I can only cancel out one of them. So this leaves me with one cosine theta on the top.
Hello, everyone.
And one sine theta on the bottom. That is going to leave me with the trig function cotangent. I apologize for the background noise. I forgot to mute my phone.